How do we do the power rules? Where you have parentheses with exponents inside the parentheses and exponents outside the parentheses. And we're talking about an outside exponent that's right against the parentheses. There's no base here. It's just attached to the parentheses. You take the inside exponent and you multiply it by the outside exponent. That gets you your brand new exponent. Now, the base just kind of comes along for the ride. And that's how you simplify that exponential expression. Again, when you have inside exponents within the parentheses and then an exponent right against the parentheses. So let's go through and try these first four right here, and then we'll take a look at this one right here. So we'll talk through this last one. You look at the base inside the parentheses, bring that on outside, then look at your inside and outside exponents and multiply them. That gets the new exponent. Now, what's happening over here with this one is that we have a negative base. See that -3 right there? That's okay, but it is sitting inside of parentheses. So what I would recommend is that you just go ahead and take the base over here, but keep the parentheses, and then look at your exponents, do the multiplication, and then make sure that you write your exponent on the outside. Okay? So that's the basics. Now, could we go ahead and figure out what 5 to the 6th power is? Could we go ahead and find out what -3 to the 12th power is? Yes, but we're just trying to figure out how do we deal with these rules when we see parentheses with an exponent inside and another exponent right there beside the parentheses. So let's go a little bit further. Let's look at one other situation down here. This is called the power of a product, okay? There is more than one thing sitting inside the parentheses. And what I mean by that is this could be a base with its own exponent, and this could be a base with its own exponent. Everything up here, one base, one exponent. So now we're saying, hey, we can put more than just one thing inside the parentheses, but we still have an exponent on the outside of the parentheses. This one's a little tricky because you don't see any inside exponents. And so what I would encourage you to do in this type of situation is to put in the invisible 1 exponents. You understand that x is to the 1st power when we don't see an exponent, but the 3 actually has an invisible 1 exponent sitting right there. And now we go and we do the same thing we always have. You steal the base, write it on the outside, over here for your answer. Then you go back to the inside exponent attached to it, yeah, that one right there, and multiply it by the outside exponent. Well, 1 times 3 is 3, so this has an exponent of 3 from this multiplication. Now, all that you have to do is go back and pick up any other bases that you haven't dealt with. So this x right here needs to be brought right out here. And then we do the same multiplication, taking the x's exponent and multiplying it by the outside exponent. Now, again, we can go ahead and we can figure out that 3 to the 3rd power is 27. Okay, that 3 to the 3rd power is 27, and then x to the 3rd power would just be sitting right here with it. And that's fully simplifying this expression. I'm more concerned about just seeing if we can get to here for right now, because then we can take it to the next steps over here. So it's like, get rid of the parentheses using the multiplication. Let's go practice this for a little bit. Now, hopefully, you're getting a little bit more comfortable with this process after having watched that. Just remember, if your base has a negative sign on it, keep the parentheses around that base. Okay, so that's the biggest issue. Now, we still have a few other situations I'd like us to take a look at, and that'll finish up the lesson here. In this type of scenario, you have these two things multiplying each other, and they're both in parentheses. You see no exponents on the inside, you see no exponents on the outside for either one. So if you want, just rewrite it. And since negative 2 is totally different than 3, yeah, you can go ahead and multiply them. Negative 2 times 3 is negative 6. And for our x's, well, we've got an x times an x. Just add up your x's here because that's what we do in this type of situation for multiplying exponents. We add the exponents actually. So x to the second. Now over here it's a little bit different. Essentially, just pretend you don't see that end of the problem first and get rid of the parentheses first. Sound familiar? We do that with equations. So let's just go ahead and make sure we see all of our exponents. Copy that first base a right here. Multiply the inside exponent with the outside exponent to get 2 right here. We see another base, copy it down here, and then multiply the inside by the outside exponent, right? So 3 times 2, that gets us 6 right here. So what we did is we got rid of the parentheses, and now this just falls down. And now we no longer have the parentheses. It's really just add up your exponents for the ones that have the common bases. A to the second times a to the third. Okay, put your a right here. And then add your a exponents. 2 and 3 is 5. Do the same with your b's. 6 and 4 would be 10. So a to the 5th, b to the 10th. In this scenario, I see no outside exponent and none inside, so this is just like a 6x without parentheses, but it is multiplying all of this, but here's the problem. This one has an outside exponent. So go put your inside exponents in so you can do the multiplication. So we've gotten rid of the parentheses here. Now this just falls down without the parentheses because again, there's no exponent on that side and we don't see anything inside. I know there's ones that exist, but we really don't need them. So it's just 6x times all of this. In this situation, I need to go ahead and figure out what 3 to the second power is. 3 to the second power means 3 times 3. So it's a 9. So 6 times 9 is 54. And now we have to take care of the x's, x to the second, and I don't see an exponent here, but I know it's a 1. And 1 and 2 together is 3, so it's x to the third power. And then this one is very much like what we've dealt with before. Now, the very last one has a negative exponent in it. And we know that we cannot leave our answer with a negative exponent in it, but it's going to show up sometimes in the problems, or we wind up getting one in the answer. But just go through and handle everything normally, and then at the end, deal with your negative exponents if there's one still in the answer. So let's not forget the 1 that's sitting there on the 5 for the exponent. Still the 5 for the base. We'll multiply the exponents, but it really is 1 times negative 2. So yes, negative 2 is what you would have to put for the exponent. We'll steal the n right here. And 3 times negative 2 gets us the negative 6 for the n. So is this a good answer? No, this is correct, but we don't allow negative exponents to sit in the answer. So draw a fraction bar, and anything that has a negative exponent, you take its base and you move it downstairs. So this 5 is connected to the negative 2 exponent. So we put it down here at the bottom of the fraction, the 5, but as soon as it goes to the bottom, the negative 2 exponent becomes positive. And then we do the exact same thing with this n and the negative 6 exponent. Notice that the 6 becomes positive when we put it down here. Now, if there's nothing left up on the top, always put a 1 right there.